Hello everyone. A very good morning, good afternoon, and good evening to all. So, dear authors and invited guests, we welcome you to the technical session 6B. I'm sorry, 7B. And my name is Anisha Mishra, and I am the moderator for today's session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the International Congress on Information and Communication Technology, ICICT 2023. The 8th edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 20th and 21st February 2023. And the virtual event is being held through Zoom yesterday and today, that is 22nd and 23rd February 2023. I hope you all will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for their presentation and 3 minutes for question and answers. And on 10 minutes, I will raise a gentle reminder. Also, there is another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, then you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chairs of the session, Mr. Daniel Johannes Hoffman and Dr. Shafi Pathan. So Mr. Daniel Johannes Hoffman is a senior lecturer and program leader at University of Pretoria, South Africa. He did his MBA MSc in Quantity Surveying Management from University of Pretoria. And Dr. Shafi Pathan. Dr. Shafi Pathan is currently working as a professor as a professor in the Department of Computer Science and Engineering, MIT ADT University, India. He has an experience of 23 years. He has worked as lecturer and associate professor in Srimati Kashibai Navle College of Engineering, Pune. He completed his PhD from JNTU, Anantapur. So I welcome you both to the session, sir.
Thank you very much, Mishra.
Shafi sir, you are on mute. Sir, we cannot hear you. Okay, so for now we are moving on forward in the session, and I would like to invite our first presenter, Yuan N. Doe, to present his paper on the title, An Improved A Priori Algorithm for Interestingness of Association Rules, a case study on the mushroom dataset. So, dear presenter, you may please present your paper now.
Can you hear me?
Yes, we can hear you.
Okay. Can you see my screen now?
Yes, we can see it.
Yes, I have recorded a video for my presentation, so I will play it now.
Hello everyone, my name is Duy and I'm a student at FPT University from Vietnam. Today I'm going to present to you my paper named An Improved A Priori Algorithm for Interpreting of Association Rules, case study on the mushroom datasets. This paper was completed under the guidance of Associate Professor Phan Duy Hùng. For presenting my work, I will proceed according to the following plan. So let's get started with the introduction. Mining association rule is a data mining problem that has been studied for a long time. The most known and simplest one for mining association rule problem is a priori algorithms, which were first introduced in 1994. However, the a priori algorithm still has a weakness in terms of computational performance because of its bottom-up and breadth-first approach. Besides that, the quality of the rule generated by the algorithm is not really appreciated due to the results contains many weakly correlated rules. So this study proposed a new approach by adding a new constraint to the joining step of the a priori algorithm. The main goal is to eliminate rules with low correlation and reduce the running time of the algorithm. So let's talk about the association rules. As you can see here, the first three ideas on the slide are the general definition of transaction database, and association rule. A rule is considered strong when support and confidence are both greater than or equal to the minimum support and minimum confidence defined by user. And let's talk about the a priori algorithm. The main idea of a priori is getting k plus 1 item sets from k item sets, which is called level-wise search strategy. In general, the priori algorithm can be divided into the following two steps: running, and the pseudocode of the a priori algorithm is presented as follows. A lot of research has been done on this domain and showing that using the confidence support framework alone is not enough to create a really good set of rules. So correlation measure has been added to address these issues. Specifically, the quality of the association rules is now evaluated for confidence and correlation. In this paper, we prefer to use two non-invariant measures, which are Coons and cosine measure, to evaluate the correlation of the set of rules. Following are the definition of these two measures. Next, I will present our proposed approach. As we can see here, from some of these mathematical proofs, it can be seen that the joining between some item sets is redundant because it does not guarantee that the generated rules have a high correlation. To solve this problem, our approach will add a constraint with a new parameter running step of the original a priori algorithm to quickly remove the rules with low correlation and keep the rules with high correlation. The pseudocode of this approach is presented as follows. For experiment, we use a bandmask dataset for association rule mining problem, which is the mushroom dataset. First, measures calculated based on the whole generated association rules are considered. From table 2, it can be observed that the higher the value of parameter d, the lower the number of frequent patterns and rules. This trend is completely understandable because increasing the parameter d will cause the constraint to be set tighter. Besides that, the measure including average confidence, average cosine, average cones has also been improved, which shows that in terms of the entire set of rules, the quality of the rules has been improved. Another worth noting point is that limiting the number of rules as well as frequent patterns also help to reduce the running time. Next, we will compare proposed algorithm with the a priori algorithm through the aspect of high correlation rules. The higher the probability of preserving the top highest correlation rules, the lower the loss of information caused by the proposed algorithm. Table 3 shows the percentage of retained rules corresponding to each of the top k high correlation rules. Here, the correlation is calculated based on the Coons values. As we can see, the larger the value of the smaller the number of rules created, and also the lower the percentage of retaining top correlation rules. However, Based on the correlation between the number of rules created and the value of k, the retaining rate is still within an acceptable level. For example, in the case of d equals 0.6, the number of rules created is 4088. The retaining rates for the top k with high value of k like top 3000 and top 4000 are 71% and 62.11% respectively, which are still acceptable ratios. Moreover, the results also show that the proposed algorithm has the ability to preserve the top k with small value of k very well. Specifically, top 200 is almost completely preserved with the lowest retaining rate being 95.8% when d equals 0.8. This is very necessary because in real-life problem, users often only need a sufficient number of base rules, not too much. Besides, in the case of d equals 0.5, almost all the top k are preserved with the smallest returning rate of 96% for the top 4000. This means with the appropriate selection for value of d, the proposed algorithm can help us get the best rule in a short time while preserving most of the information obtained by the original a priori algorithm. Conclusion. This work presents a new approach based on setting new constraints at the joining step of the a priori algorithm. The main contribution is to filter those rules with high correlation and improve the running time of the original algorithm. Experimental results on mushroom datasets show that this approach not only minimizes the running time by eliminating the rules with low correlation, but also ensures that the retaining rate of top rules at an acceptable level. So this is my presentation. Thanks for your attention.
That's my presentation. Do you have any question?
Fine. The first thing you said that you are taking advantage, you are reducing the time of a priori algorithm, isn't it?
Yes, I add the constraint in the joining step of a priori algorithm, and I eliminate the rules with low correlation, and that eliminate lead to the reduce in running time.
Acha. So for calculation of running time, what is the system configuration you on which you executed?
You mean the setting parameter or the environment?
I am saying about infrastructure. I mean processor configuration, memory of the system.
Yes. I do on the experiment on my personal laptop, and it's the Intel Core i3 and 7 Gen and Dell Inspiron 15. Yes, it's an O1.
Acha. Fine. Now, can we do calculation which will be independent of system configuration? Can we have that calculation?
I just using the VS Code.
No, I am saying independent of system configuration. That means algorithmic point of view.
Can you repeat? Sorry, but I.
Acha. Fine. Do it is good to know these things. It is all from my end. Thank you.
Yes, thank you so much.
Hello, Hoin. Thank you for an interesting presentation. Just two questions from my side. First of all, was the result that you get to, was it according to what you expected or your hypothesis? And secondly, what would you recommend to take your finding forward? What next need to be done?
Yes. In this research, I will base on this research and develop and improve in terms of high utility item set mining. You know, this paper is just item set mining in a traditional item set mining, and in the future I want to develop and improve in terms of high utility item set mining based on this idea.
Thank you. That's all from me. Thank you very much.
Thank you very much.
Okay, so thank you for the presentation. And now we are moving forward to our next presenter. And I would like to invite Manar MF Thonia to present her paper on the title Anomalous Aggressive Event Detection Techniques. So dear presenter, you can please present your paper now.
Okay. Good evening. I am Manar Dunya. I'm going to present the latest techniques used in the detection of the anomalous aggressive event. Anomalous behavior is the human attitude that drifts from anticipated common or natural action. Aggressive or violent ones are the most harmful among them. We focus on the present trend of detecting aggressive behavior. Detection of such behavior has a critical role in public safety and security. Recent studies categorized into three models: traditional learning-based model, deep learning-based model, and hybrid model. Traditional learning-based model depend essentially on two steps: feature representation, which focus on extracting set of handcrafted features and pass it to the next step, which is feature analysis. It employs a machine learning classifier to classify an event as normal event or anomalous event. In feature representation, instead of using raw data, which causing the curse of dimensionality problem, researchers focused on extracted engineered feature to reduce raw data without sacrificing critical information, to decrease the computational complexity. The extracted features are varied between audio and visual clues, where visual clues can be represented through appearance features or motion features or a combination between the appearance and the motion. Some researchers focused on the audio signal feature. Audio signal have frequency components that combine together to make the sound we recognize. Buther Joe et al., also Sermon and Cert, detected aggressive behavior using audio type data through extracting set of features such as zero crossing rate to form engineered features. Other researchers focused on a visual feature. They represented through an appearance feature. An appearance features focused on the shape of a human body during an action. It can be categorized into interest point-based method, which focus on the feature that localized on a point of interest of an image. Lamba et al. Used Harris corner detector. They extracted edges and corners of a human body during an action. Khan et al. Used the scale invariant feature transform method, which focus on a local surrounding of a set of interest point of an image. The other method is local appearance-based method. It describes a local object shape within an image. Das et al. Use a histogram of oriented gradient. They focus on the structure of the human body during an action by counting the occurrence of age intensity orientation. Other researchers represent the visual feature through a motion feature. The motion feature focuses on the direction of the moving body part. Different algorithms are applied to capture motion features, such as motion vector extracted per block of pixels. SN et al. Use a block matching algorithm to extract one motion vector per block of pixel that represents the displacement of each block of pixel between two successive frames. Other extract a motion vector around a sample of point. Yu et al. Use the sparse optical algorithm to extract the motion magnitude and orientation around a key point of interest. Other, extract a motion vector for each pixel in the frame. Berentu et al. Use the dense optical flow algorithm to extract the motion magnitude and orientation feature for all points in the frame. The feature analysis is the second step of traditional learning-based model. It distinguishes a violent from a non-violent action through employing a machine learning classifier, such as entropy classifier, K-nearest neighbor classifier, random forest, decision tree, and support vector machine. Jalal et al. Use an entropy classifier, which based on the probability distribution to determine different interaction classes. They achieve an accuracy of 91% in detecting violence. Nadim et al. Use a K-nearest neighbor classifier, which determine the interaction classes based on feature similarity. It measures how similar or related to items are using distance measure, which achieve an accuracy of 83%. Gro et al. Use a decision tree. They achieve an accuracy of 89% in detecting violence in violent flow dataset. Roshan et al. Uses support vector machine classifier. They achieving an accuracy of 91.5% in detecting violence in hockey-fied dataset. The second model used is deep learning-based model. It performs automatic feature extraction without human intervention. A deep learning model is self-learning representation. It skips manual feature extraction step and deals directly with the raw data. Several algorithms are used in deep learning model, such as convolution neural network, autoencoder, deep leaf network, or recurrent neural network. The convolution neural network model consists of different types of neural layers. Convolution layer, along with rectified linear unit, to generate a feature map. Pooling maximum layer to reduce the dimension of the feature map in order to reduce it computationally. Followed by fully connected layer to map the extracted feature into the final output layer, which classify an event as normal or anomalous event. Different types of convolution neural network model have been used for violence detection. Dewey et al. And Louis et al. Use a ResNet model of 50 layers deep. Mumtaz et al. And Kubaker et al. Use a GoogleNet model of 22 layers deep. Nevelgand et al. And Kumar et al. Use a VGNet model of 16 layers deep. Other use an autoencoder. An autoencoder consists of encoder that convert the input into code and decoder that reconstruct the input again from the code. Debak et al. And Gang et al. Use the autoencoder model to detect an anomaly through learning normality. The autoencoder model learned the feature of the normal action, so it predicted it with a minimum or a small reconstruction error. While reconstructing data from anomalous action, the autoencoder will struggle and has a higher reconstruction error. The high reconstruction error is used to label the anomalous action. Some researchers adopt a fusion strategy, depending on multi-model, to obtain more discriminative feature. The extracted feature of convolution neural network model are fed into recurrent neural network model through removing the output layer of the fully connected layer and take the output, through removing the output layer and taking the output of the fully connected layer and give it as input to the recurrent neural network model. The most recurrent neural network are long short-term memory, bidirectional long short-term memory, and gated recurrent unit. Simon et al. Fed the extracted feature from ResNet model into long short-term memory model. Hansen extracted special feature with VGNet model, followed by bidirectional long short-term memory model to extract the spatiotemporal feature. Dashmek combined both VGNet model with a long short-term memory model. Imran et al. Combined the mobile net model with gated recurrent unit model for feature representation. Badal et al. Proposed a hyper deep network model where the special features are extracting using Inception version 3 plus a ResNet model, followed by long short-term memory model for temporal feature. The output layer of the deep learning based model provide a prediction. The most commonly activation function used in the output layer are softmax function and sigmoid function. The softmax function normalizes the output of a network to a probability distribution over output classes. It used by UL et al. They achieve an accuracy of 87% in detecting violence in the UCF crime dataset. Sarmigal et al. Achieving an accuracy of 90% in detecting violence in 500 crime scene video collected from the internet. Jung et al. Also uses softmax activation function that achieve an accuracy of 98% in detecting violence in violent flow dataset. The other activation function used is sigmoid function. It applied to binary classification problem. It returned a value between 0 and 1. It used by Bitter et al. Achieving an accuracy of 92% in detecting violence in hockey-fied dataset. Simon et al. Achieving an accuracy of 97% in detecting violence on the Bangladesh crowd dataset. Islam et al. Also use the sigmoid activation function. They achieve an accuracy of 100% in detecting violence in the movified dataset. The last model is the hybrid model. The traditional learning-based model provides a way to visualize and analyze the feature, but it has a wide-ranging feature that increases computational complexity. The deep learning-based model offers end-to-end problem solution. However, due to its multi-layer structure, it's not easy to be traced. It will be challenging to solve any problem that arises. Some researchers investigate the advantage of integrated both models to overcome their obstacle. In such a model, a classical machine learning classifier trained on feature extracted with a deep learning-based model, or a deep model fed with engineered features. Shai et al. Use the VGGNet for feature representation and support vector machine for feature analysis. They achieve an accuracy of 95% in detecting violence in hockey-fied dataset. Akotule et al. Extracted deep feature with convolution neural network model and analysis them using support vector machine classifier. They achieve an accuracy of 99% in detecting violence in violent flow dataset. Shatter-Joe et al. Used a one-level discrete wavelet transform was used to extract a special feature, which fed it into bidirectional long short-term memory for feature analysis, achieving an accuracy of 94% in detecting violence in hockey-fied dataset. Fennell et al. Extracted appearance feature using a histogram of oriented gradient descriptor and fed it into bidirectional long short-term memory for feature analysis. They achieve an accuracy of 94% in detecting violence. Rondon et al. Extracted motion feature using an optical flow algorithm, which fed it into multi-model of DNSNet and bidirectional long short-term memory for feature analysis. They achieve an accuracy of 95% in detecting violence. Detecting an aggressive event. Conclusion: detecting an aggressive event in video surveillance faces a series of challenges: ambiguity, dataset quality, lack of positive samples compared to negative in dataset. Lack of positive samples compared to negative in dataset. Detection approaches are traditional learning-based model, which deliver the opportunity to visualize and analyze features. Its strength lies in engineering feature that largely contribute to the result. Its weakness is wide-ranging feature increases computational complexity. Deep learning-based model offer end-to-end problem solution. It manipulates raw data to extract the information to create knowledge. It performs automatic feature extraction without human intervention. Its weakness: the amount of learning depends on the quality and the quantity of the data, which affects the result. Hybrid-based model integrate both models to overcome the obstacles and obtain the benefits. The combination of both models gives a strong baseline by extracting more discriminative features. Currently, the researchers are attempting to raise the rate of violence detection by making various alternations in each of the examined models to achieve the best possible outcome. Thank you for listening.
Manar, nice presentation, first of all. 1 minute. Hi, Mana.
Yes.
Actually, as it is shown that it is aggressive event detection technique. Fine.
Yes.
It seems that actually whatever study you have done or it is shown, it covers almost it covers a very it covers almost everything, isn't it? It is good. It is nice. But are you proposing something out of it?
But I what?
Are you proposing something out of it?
No. No, it's a review. It's a review paper about the latest techniques used in the detection of the aggressive behaviors.
Acha. So, in that case, in one of the review technique, I have seen that in movie data set, it is stated that 100% accuracy is there.
Yes.
Yeah. So, what is your
In
say about
movified
it?
data set. In the
Yeah,
movified
yeah.
data set,
It is
it
100%
achieving
accuracy.
100% accuracy.
Yes,
But it's
that
only
is my,
it happened only in one data set, movified data
ye-
set.
yes, Manar. That is the proposal by that author, isn't it? That is proposal by Islam.
Yes.
What is your say about it? What is your say?
I can't understand the question. What?
What is your say? Means he is saying that 100% accuracy. Do you think that it is possible or it can be achievable in that way?
To be sure that it can be achieved, I need to test his algorithm. But
Fine.
the movified data set, its advantage is it's an easy data set.
Acha.
So
Okay.
I think it can be achieved
Acha.
because there is not a lot of variation of actions in the movified data set.
Acha. Now, what is your say about hybrid methodology? Which combination is good according to you? Which combination will be good according to you?
I think a combination that combined engineered features with the deep learning model. Because the main problem of the deep learning model that we can't know which feature it will work on.
Acha.
It deals with raw data.
Fine. Manar, good presentation and nice interacting with you. So it is all from my end. I wish you good luck. Thank you.
Thank you.
Hello, Manar, from my side. Thank you very much. Very interesting presentation. I just want to know if you can maybe inform us if any of this has gone beyond research. Are they, for instance, being able to apply this in, let's say, combine it with drone technology for crowd control? Would that be foreseeable? Do you know anything, and can you enlighten us on that?
Sorry, can you repeat the question?
No, I'm just asking about the practical implications of this type of research. Has this been actively applied by companies or governments or police forces for crowd control? And has they, for instance, been able to combine it with drone technology, that you don't work from a stagnant camera, but that you use drones to assist you with crowd control?
I think it's interesting point that now there is a lot of cameras, security cameras in a lot of places to monitor violence, to stop it at initial spark. So actually, I don't know if it's actually implemented by government or not, but it's it will be very interesting to be implemented, but I don't know if it's really implemented or not.
Thank you. Thank you very much. Nothing else.
Thank you.
Okay, so thank you so much for the presentation.
Thank you.
And now we'll move further, and I would like to invite our next presenter, Luis F. Guerrero Vescas, to present his paper on the title HUM, a novel algorithm based in blockchain for security in SD-WAN controller. So, dear presenter, you can please present your paper now. Okay, so I think Luis is not here in the meeting. So for now, we are moving forward to our next presenter. Yeah, and I would like to invite our next presenter, BM Ahmed, to present her paper on the title Interpolated Solutions of able integrated equations using barycentric language double interpolation. So dear presenter, you can please start your presentation now.
Hello, everybody. I'm here. Can you hear
Yeah.
me?
Yes, we can hear you.
Today, I am presenting interpolated solution of Abel integral equation using barycentric Lagrange double interpolation. Presented by Engineering Basma Magdi Ahmed, Assistant Lecturer in Physics and Mathematics Engineer, Faculty of Engineering and Technology, Future University in Egypt. Outline, Introduction, the presented computational method, computational results, and conclusions. Introduction. Integral equations appear in many scientific applications in fields of scattering theory, potential theory, radiation theory, radar, and effects of magnetic field on versus artificial intelligence, genetic engineer, nanotechnology, and other fields. We presented an interpolation method based on matrix vector, barycentric, and single and double interpolation formula for solving Abel integral equation. The main goal of this method, we interpolate both the given data function and kernel. We apply new matrix vector, barycentric, single, and double interpolation formula. We can totally eliminate the kernel singularity when one variable approaches the second variable. Using rule, we created 4 nodes distribution of kernel variables. The proposed method presents a new rule for isolating the kernel singularity, which involves selecting the best node distribution for the 2 variables to ensure the denominator doesn't be imaginary or 0. When compared to the solutions provided by other approaches, we found to be converged to the exact solution with a minimum CPU time and high accuracy, demonstrating the novelty and simplicity of our suggested method. The proposed method, interpolation solutions of Abel integral equation using barycentric Lagrange double interpolation. Consider linear Abel integral equation as shown in equation number 1, where f of t is known smooth function, u of t is known function to be determined. The kernel is given by k of x to t equal x minus t power negative alpha. Furthermore, the interpolate unknown function un of x, then un of x equal, as shown in equation number 2, here w equal omega I is diagonal square matrix, Lx of x is row monomial basis matrix, and U is column unknown coefficient matrix, and C is square non-mapping coefficients matrix of barycentric functions. Similarly, the data function f of x can be interpolated to produce the matrix vector as shown in equation number 3. The kernel will be interpolated with respect to variable x and t. To obtain matrix vector, double interpolate kernel kn of x to t. Consider the strategy of choosing xi and di in such manner that the denominator of the kernel never becomes 0 or never contains complex number, as an inevitable results of always being x greater than t. Hence, we put xi equal mu over 2 plus I h1 when h1 equal mu over 2n. Ti equal I h2 equal mu over 2n plus delta. Hence, we can get the matrix vector double interpolate kernel kn of x of t as shown equation number 5 for alpha equal half. The solution of 1 is given by as shown in equation number 6. Thus, we get interpolate unknown function un of x as shown in equation number 7. We can get another formula for the interpolate solution unx without interpolate the data function f of t. In the case, we get equation number 8. Now we get computational results. Given e power x minus 1 equal integral from 0 to x u of x over root x minus t with exact solution u of x equal e power x over root by root x, we use the formula for delta equal 3 with x equal 0.1 to 0.5, step size 0.1. For delta equal 2, we put x 0.6 to 1, step size 0.1. We apply formula 7. We get now table for interpolate solution using our method and calculate the absolute error. This table shows the results of solution for n equal 2. The first column is exact solution, the second column our interpolate solution, the third column is absolute error and CPU time. The results shown our interpolate solution is strongly converged to exact solution that shown in table number 1. Figure 1, the comparison between exact solution and interpolate solution. As shown in our figure, strongly converge to exact solution, our interpolate solution. Conclusion, from this method, matrix vector pericentric double interpolation method, it turns out that the complexity of calculation is remarkably reduced. The proposed method offers interpolated solution strongly converge to exact solution. Two rules were designed to prevent the kernel denominator from tending to 0 or holding a imaginary number, thus isolating the kernel singularity. The interpolate solution is substituted twice into the right and the left sides of integral equation, resulting in an algebraic system without applying the collocation method. The time is saved. Our CPU time in last column shown our advantage of this method. Round of error is minimized. The high precision of the data obtained using the proposed method and CPU utilization demonstrate the uniqueness and effectiveness of our work. Thank you. Thank you. Any question?
Hi, Basma.
I
This is Pathan. That's fine. A nice presentation is given by you, and especially it tells about mathematics behind image processing, if I'm not wrong, isn't it? But
can you repeat
in
again? I
in
can't hear you, please, sir. Can you repeat again?
Acha, one thing I want to ask, right? You go to that table, CPU computation table.
Okay. Give
Go
me
to that
1
table.
minute.
Yeah.
Okay.
Now you have drawn the graph, fine. One is CPU time of yours, and what is that second line represent in the graph? Go to the graph.
Um,
Go to the graph. Uh,
okay.
First is UX, and second is U2X. Can you show me these values in the table? The graph. Can you correlate graph and table?
The vertical line, the value of x. The horizontal line, the value of ux. When x equal 0.1, u of x equal 0.25, as shown in graph. When x equal to 0.2, u of x equal 0.32, as shown in graph.
Acha.
Um,
In some cases, actually in a graph also, we are not able to find a remarkable difference between interpolated values and exact solution. What is your say?
exact solution, black line.
And you are saying that interpolated solution is better one, isn't it?
Interpolated solution, the exact solution, this line, and the interpolated
Is a-
solution is this line.
uh,
Can you understand me?
this line, which we, acha. Now in that case, which means these two lines more or less are going in parallel, yes or no?
No, no parallel. They strongly converge because it
Where they are
is
converging.
a.
Huh?
Please repeat again. There are interpolate solution and exact solution strongly converge as shown in figure. And
Yeah.
the table, this is
Yes.
exact solution. This is interpolate solution. Strongly converge.
Acha, fine. So is it that is your objective that they should converge?
Please repeat again.
Is it that is what we are supposed to achieve? They should converge, you are saying?
I can't understand. I can't hear you. I'm sorry.
Acha. Fine, Basma. It's okay. It is all from my end. No issue. Wish you all good luck.
Thank you.
Hello, Basma, Dani Hoffman here. Thank you very much for this presentation. I don't have much to say. I think the work was interesting. I would just like to know, was your study more focused on increasing accuracy or on saving computer time? What was the main focus, and were you happy with your end result?
When I increase the value of n, the accuracy of the interpolated solution will be increased. But there are take more CPU time.
All right. Do you intend to follow the study and to pursue this methodology further and develop more, or what do you foresee that you'll be doing next?
I will be study it in future. I study
Thank you.
it
Thank you. Yeah.
in equal to honor.
Okay.
I will be study it for in more than equal to.
Thank you. Thank you very much.
Thank you.
Okay, thank you so much for the presentation.
Thank you.
And now we are moving forward to our last presenter for the session. And I would like to invite Nikolay Pavlov to present his paper on the title, Study the Launch Process and Acceleration of a Rear-Wheel Drive Electric Vehicle. So dear presenter, you can please present your paper now.
Thank you. Hello, everyone. My name is Nikolay Pavlov, and I am associate professor at the Technical University of Sofia, Bulgaria. I will present you our work on study the launch process and acceleration of a rear-wheel drive electric vehicle. The structure of the presentation is it consists of introduction, experimental equipment and results, numerical calculus, and conclusion. When vehicles move in urban conditions, their motors work for a long time in a transient mode. Frequent launching or starting, accelerating, decelerating, stopping, and starting again is required. In this regard, the study of the dynamics of launching and accelerating electric vehicle is a topical issue. There are some differences in the starting and acceleration process of front-wheel drive and rear-wheel drive vehicles. In front-wheel drive vehicles, under the action of the inertial force during acceleration, which is directed backwards, the front drive axle is unloaded. This results in a reduction in the ability to transmit traction force between the drive wheels and the road. During intense accelerations, slipping occurs and the inability to transmit the maximum available torque of the traction electric motor to the road. Slipping can be reduced or prevented by using system for launch control or traction control. In rear-wheel drive cars, the inertial force during acceleration transfers the weight to the rear drive axle and improves the conditions for transmitting maximum torque from the traction electric motor to the drive wheels. In sport cars with high power and torque of the traction electric motor, slippage is possible, although less likely than the front-wheel drive vehicles in the process of starting and intensive acceleration. And this can also be compensated by using systems for launch control of traction control, the improved traction performance when starting, as well as the good stability during regenerative braking with only an electric motor when driving in a corner of the rear-wheel drive electric vehicles determines their wide use in modern electric cars built on specially designed new type of platforms. Such examples are the BMW i3, the new Tesla Model 3, Porsche Taycan, Volkswagen ID3 and Volkswagen ID4, when they are not in four-wheel drive variants, only their rear wheels are driven. The return of rear-wheel drive powertrains is observed, which the most automotive companies had abandoned, as the wide constraints and design problems of torque transmission using a traction electric motor are not as big as like the rear-wheel drive conventional cars with internal combustion engines. In this paper, the launch and acceleration process of a rear-wheel drive electric vehicle is experimentally studied using a single sensor, only one accelerometer, and appropriate computational approach to obtaining the results for the driving speed and distance traveled is presented. Here you can see the experimental equipment. We have accelerometer. I want to tell something about the conventional methods of studying the launch process and acceleration. In conventional, traditional methods, they used so-called fifth wheel, usually, or another device, non-contact radar sensors. These devices have a high price and require external mounting on the car body. But in this study, only in-vehicle mounted accelerometer is used. The experimental equipment consists of an accelerometer mounted on the horizontal surface of the front panel of the electric vehicle on the dashboard. Its measuring range is plus minus 2 G. Frequency range from 0 to 200 hertz, and sensitivity 1000 millivolt per G. Its sensitive element is capacitive silicon silicium micro electromechanical, or MEMS. The output signal is analog, and an analog to digital device of the Hottinger-Baldwin mesh technique is used to convert it for visualization and recording on the hard disk of a mobile computer. The vehicle studied is a pure electric vehicle with permanent magnet motor driving the wheels from the rear axle. Here you can see the parameters of the studied vehicle in this table. The nominal electric motor power, the nominal electric motor torque, number of seats for including the driver, it's for 4 seats car. Here you can see the forces acting on a vehicle during straight line acceleration on level road, where G is the vehicle weight, Z1 and RZ2 are the normal reactions on the front and rear wheels. Ft is the traction force from the rear wheels. FF1 and FF2 are the rolling resistance forces. Fa is the inertial force. Fw is the aerodynamic drag or wind force, and A is the acceleration vector. H is the center of gravity height. L is the wheelbase of the vehicle. The driving limits determining maximum vehicle accelerations limited by adhesion between tires on the drive wheels and road can be calculated by this formula. A mu is the maximum possible acceleration determined by the adhesion. Mu is the coefficient of adhesion. Fr is the rolling resistance coefficient. Here is their numerical values. G is the gravity acceleration. Delta A is the rotational inertia coefficient. Here is given 1.08. Usually in electric vehicles, because of the lack of the flywheel, This coefficient is smaller than in the conventional vehicles with internal combustion engines with flywheels. D mu is the maximum possible dynamic factor for rear-wheel drive vehicle determined by the adhesion. Here is the formula for the dynamic factor for rear drive vehicles, where mu x is the adhesion coefficient, and here is given 0.8 like a dry pavement and tires with good quality. Here is the results from these calculations. And the test was conducted in real-world conditions in dry, windless weather on a level road with dry asphalt surface in good condition. Launching was done by pressing the accelerator pedal to the bottom position at the start. In this way, the maximum power characteristics of the electric vehicle are realized right from the beginning of the studied process. The pedal is pressed in fully bottom position until the car reaches its maximum speed. During the test, only the acceleration time series is recorded using the accelerometer mounted on the front panel of the car. The results obtained during the test are shown in this figure. The maximum realized experimental acceleration is 3.8 meters per second squared. The obtained theoretically upper limit for the acceleration was 4.16 meters per second squared at an adhesion coefficient of mu x 0.8, corresponding to good grip between the tires and the dry asphalt, and it is higher than experimental, which means that no slippage occurred. The driver also didn't notice any signs for slippage. This means that the full power and torque of the traction electric motor has been realized because the accelerator pedal is fully pressed. To obtain the other characteristics of the vehicle movement when starting and accelerating, the methods of numerical calculation are used. Numerical integration must be used to obtain the speed. The using of trapezoidal method in MATLAB is possible. And this figure shows the results obtained in this way for the speed of the car. From this graph, it's easy to determine the main parameters like the time to reach maximum speed. Here we can see the time to reach maximum speed and the time to reach, for example, 100 kilometers per hour. The obtained results for speed can be used to make a graph of acceleration versus vehicle speed. And after the numerical integration of the speed, the distance is available and plotted relative to the time in this figure 5. The section where the acceleration increases from 0 to its maximum value on the graph of an acceleration versus speed give us information about the response of the electric motor to the electric vehicle launch process at fully pressed accelerator pedal. In electric vehicles with lower motor power, as well as in electric vehicles with higher weight or with a higher rotational inertia coefficient, the time to reach maximum acceleration is higher, this branch. This figure shows the results for vehicle speed relative to the distance traveled. The time to travel the distance of 0 to 400 meters, which is the main parameter for dynamics of the vehicle, and the top speed are another important indicator for comparing the vehicle dynamics. And in conclusion, the paper shows the results of tests carried out in real-world conditions. Only one sensor was used to measure acceleration. The remaining parameters of the launch process and acceleration to top speed were obtained in software by numerical integration using the trapezoidal method in MATLAB. The results can be used to evaluate and compare the dynamic properties of electric vehicles. Similar software can be developed for a smartphone application. The application can find popularity among drivers to easily test their electric vehicles performance and even diagnosis of the technical condition of vehicle. When we know the initial parameters and after a long time of using a vehicle, you can compare these parameters with the initial. This research is supported by the Bulgarian Ministry of Education and Science under the National Program Young Scientists and Postdoctoral Students too. Thank you for your attention.
Hi, Nicola.
Hi.
Yeah, it is good to know the study. The most important, we are able to see that it is sponsored and funded by the government of Bulgaria, isn't it? The whatever study you have shown, what are the takeaway of this study? Can you elaborate once again? What will be the takeaway?
What to tell you? Sorry.
What are the takeaway? What at the end, what we want to achieve means what are objective?
We want to show that only a single sensor accelerometer can be used to take results for main parameters of vehicle dynamics when start or launch and accelerate, and from 0 to maximum speed. And in our future work, maybe we will try to make application for a smartphone use of this algorithm with numerical integration of the acceleration results to speed and distance traveled, and it can be used for measure these parameters in electric vehicle, especially because in conventional vehicles we have gears, and there is difficulties to measure when we change gears. But in electric vehicles, we only press the pedal and we can take results for the whole process from 0 to maximum speed.
Gotcha. Because I remember the first diagram which I have seen, where vehicles are there and with which vehicle a battery symbol is shown, which says that different variation in the battery level of the vehicle, isn't it?
Yes, yes.
Fine. So I thought it is a correlating with that battery and acceleration. Is it like that? There is a relation between present battery condition of the vehicle and your acceleration.
In our studio, we don't have we
Yes.
don't consider this relation, but you are your decision is right. The acceleration is very important factor for battery. The given the battery of the energy from the battery. When acceleration is higher, the energy from the battery is more. The consumption from of the energy, and maybe it can be taken consideration. But in this study, we consider only the dynamics, the dynamics aspect, acceleration, speed, time, not energy.
You might have used a very good paper as a references for your study, but as a whole, I'm not able to find that literatures and papers supported document for your state of art structure or supporting uh, study for your study. So try to include it, or if it is included, try to have elaboration on it, or try to show it, represent it rather than. That is one part I think it is missing. But it is observed that it is a very good study or very good project you are working on it, and I wish you all good luck and thank you very much.
Thank you very much.
Hello, Nikolai, Donnie Hoffman here. Thank you for a very interesting presentation. Just one or two things that I'd like to talk or ask you. It seemed to indicate that you work a lot with that BMW vehicle. Did you share your findings with BMW, and what was their reaction?
No, because this type of vehicle is available here in Sofia, like a company for rent a car, and it was our decision to take from rent a car, but it is the rear drive vehicle, and I think it is interesting because the dynamics of rear drive vehicles are better when they accelerate. We don't share this study with people of this company. Maybe they will read the proceedings and okay.
And the other thing I want to know is, I know you said you only used one unit or one measurement unit on the study. Did you at all consider this the difference in slippage between the left and the rear wheel on the rear axle? Like you have a limited slip differential in a 4-track vehicle and that type of slippage, or did you assume that the road quality is such that there's equal slippage between the two tires and therefore that was not part of the study?
We performed a study on dry asphalt, and our calculation, theoretically calculation, give us information that maximum acceleration on good quality pavement will be 4 point more than the given in the experiments, and I think it is enough to say that the slippage it wasn't occurred, and the driver don't feel any signs of slippage when he started. But when if we have another type of road, the results will be not the same. We have to consider the slippage.
Thank you, but thank you very much. Nothing else for me. Very enjoyable. I really enjoyed listening to you. Thank you.
Okay, so thank you so much for the presentation. And now, as we have completed all the presentations for today's session, I sincerely thank all the presenters for their excellent presentation and all the participants for being a part of this international conference. I hope the session was informative enough for you all. Yes, sir.
Anisha ma'am, please give me 1 minute also to say my courtesy.
Sure, sir.
Thanks, sir. Should I go? Is it fine if I can go? I may
Yeah,
go.
sure. Yeah, please.
First of all, thank you to organizers, international conference organizers, for considering me as a reviewer session chair. Thank you to my friend, Dr. Nilanjan Dey and Dr. Joshi, that is one of the organizers from the conference. Thank you to all the participants. We are able to, I enjoyed the session. The reason being that I learned many things, starting from a priority algorithm to the acceleration detections and all these things. Attending the conferences like these is always a feast, or it is always a learning experience. So we are always happy to be there for the conference or for any type of work. Thank you to my new friend Daniel. I hope it was nice to hear you, nice to see you. And thank you to Anisha ma'am for nice introductions, being with us. And let us hope that we'll meet in future also. So thank you and have a nice day. And it was a happy learning for me. I wish you all good luck and happy moment in the life. Thank you and good day.
Thank you. Good day.
Thank you, Anisha
Um,
and Prof. Shafi from my side as well. A very enjoyable session, interesting topics. And also from my side, thank you for the organizers. There's always a lot of effort and a lot of energy that goes into organizing these events for us as researchers
True.
and for our students to get our views across and to present our work to audiences and get feedback on that, which is very valuable for us. Thank you very much for all the organizers and all the events. Thank you for people like Anisha who assist in the session and running it smoothly. Really appreciate it. And thank you for Prof. Shafi for your interesting comments.
okay. Thank
Yes,
you
sir.
so much, sir, for your kind words. And we thank you for your support during this version and the previous 7 versions of the conference. And we will be happy to have you in the 9th version in 2024.
Yes, ma'am.
Okay. Yeah.
Thank you.
So,
Looking forward. Thank you, guys. Good luck.
and yeah,
Thank
and
you.
all the presenters would be getting their digital certificates through email within 2 working days. And all the papers have already forwarded to Springer. So the publication will be live within 6 months. So kindly cooperate with the team of ICICT 2023.
We will be also
And
getting certificate, isn't it?
yes,
We
sir.
will be also.
So I'm just getting into that. And
Yes.
I would also like to thank our session chair for chairing the session. And here is a small token of appreciation on behalf of the team of ICICT, Global Knowledge Research Foundation, and the partners. So thank you so much for your valuable presence, sir. And now that we have come to an end of the session, I request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care. Bye-bye.
Thank you.
Safe. Thank you. Goodbye.
Bye bye. Thank you for support.
Bye, sir.
You.